Hello everyone, welcome to the second example. This time we will use for loops for the solution. And as an example, we have taken an exercise that takes an input, so ask the user to provide an input, a number, a natural number greater than 1. And our duty is to determine whether this number is prime or not. So what is a prime number? Is a number that cannot be expressed as a product of other two numbers. So let's take the sequence of the first numbers that we know. So 1, 2, 3, 4, 5, 6, 7, and so on. Prime number, first of all, should be greater than 1, so 1 is excluded, it's prime by default. And we have to evaluate whether any of these numbers can be expressed as a product. So n is equal to something like a multiplied b, where a and b are both smaller than n. So for example, 2 cannot be expressed as a product of two numbers smaller than 2, because smaller than 2 it is only 1. So there is no way to have 1 by 1 equals 2, so this is prime. 3 as well, we have only two former numbers, and none of the combination 1 per 2 or 2 per 1 can give 3, so still this is prime. 4 is not prime because it can be expressed as a multiplication of 2 by 2. So this is not prime. 5 as well is prime because there is no combination between 1, 2, 3, and 4 that the multiplication of these, any couple of numbers can give 5. 6 is not because we have 2 by 3 or 3 by 2 that gives 6, so it's not prime. 7 is prime, and so on. So our duty is, given a number, say 7, we have to determine whether this number is or it is not a prime number. What we have to do? So we have to evaluate whether the sequence of the numbers smaller than 7 and greater than 1 can be used in order to have an expression such as 7 equals any of these numbers, which I'm calling, I'm using an index I, for some other number. In other words, we need to evaluate whether 7 module I equals to 0. If it is, then it means that there exists a number that multiplied by I can give 7, and the remaining is 0. So this is the mathematical expression that we can use to identify whether 7 falls in such case, in such scenario. The first step, we have to generate all the numbers between 1 and n, because to us, 7 is just an example, but it is parametric. So n is the given number provided by the user. So as a code, let's start first of all asking the user to provide a number. So my number equals to int input, enter the number to evaluate, just a new line. Okay, how to generate a sequence between 1 and n, in this case num, but excluding the first number 1 and the number entered by the user. Let's use the method range for I in range. We have seen the use of this method in a former lesson. And let's print the value I. So we want to start, so exclude number 1, the first number, and exclude as well the last one. If you remember, range, the method range, start or generate a sequence starting from 2 till n minus 1. Let's enter the value, let's say 8. Okay, it generates from 2 to 7. Okay, but what we have to do with this I, we have to evaluate whether n entered by the user module I equals to 0. Print num, str num, a message saying that num is not a prime number, because whether I find such number okay, let's do a test. Run, let's say 6. 2 times it says that it's not a prime number. Why it's showing it twice? Let's print as well for which value of I it has generated. I'm just writing some token in order to see for each value of I, it turns to be, and as expected, for values 2 and values 3, 6 appears not to be a prime number, which is correct. 6 might not be prime because of many numbers. So if the number is large, obviously there will be many numbers that are multiple or 6 or can be divided by 6 with the remaining of 0. But what we need is to find only the first one. We do not need to go any further. So instead of finding all numbers, we are not interested in all of them, we are interested in just one of them. Then, if you remember, whether there is no need to go any further, we can break the loop using the instruction break. Let it run again, enter 6, and okay, with I equals to 2, we have identified the fact that 6 is not a prime number, and we have stopped there. We did not continue any further because there is no need. Okay, but I want to print in the standard output whether it is a prime number. Here, else, would it work? Let's see what we have in output. Else, let's say, is prime. Enter 6 is not. Let me enter another number because at some point it says that 9 is a prime number, most probably because of the number 2. For I equals to 2, this was not true, and it executed the alternative, which is wrong, because we have to be sure that none of the former numbers can satisfy this condition. So we have to check all of them. And if none of them satisfies it, then we can claim that that is a prime number. So this doesn't work. What we have to do before we break, so I'm keeping this print. So we have to do an assumption. We assume that is prime equals to true. So we consider every number as a prime. If, while trying all the smaller numbers, we find any case where this condition is true, we need to set prime equals to false. And we can break the loop because we have found at least one condition where n, so the number, a module I, has the remaining of 0. So at the end, we have nothing but to evaluate whether prime is true or not, and say prime. So if this condition is true, that we can print out str num is a prime number. And else it is not. Is not a prime number. The idea is that we consider each number as prime and we test. If we find in any range between 2 and n minus 1, so if we evaluate number 7, if we find in any of the numbers in the range between 1 and 7, by excluding these two values, any of these, at least one, that the module of our number based on I equals to 0, this number, in this case 7, would not be prime. So if none of the former or none of the numbers that we have generated satisfy such conditions, it will never turn to false. It will remain always true. Though, if this is never true, this will remain. The value or the variable is prime will remain true and nothing will change it. So if we have tested all the possible values that could break this condition, then we can claim that we have tested all the former numbers and none of them were true. We can claim that this number is prime. Otherwise, it is not. Let's test it. Let's say 8 is not prime. Let's say 9 is not prime, obviously. Let's say 11. I'm expecting 11 is a prime number. 12, it should say not prime. Okay, and 13, I'm expecting to say prime. Okay. So we have used the for loop parametric because the range that has been generated depends on the value in input, and have evaluated whether all the range of values generated by the for loop whether any of them, at least one of them, satisfies the condition in the if. Now, to make it a little bit more complicated, let's add another request. So given a natural number n greater than 1, print all the prime numbers between 2 and n itself, if it is a prime number, because it might be. So what we have to do, if the user's input is the number 7, I have to print in the standard output 1, 2, 3, 5, 7. So print all the numbers from 1 to 7 that satisfies the condition of being prime. Before I do any evaluation, first of all, I have to generate this new range. So I'm using another index, another variable for the index, for in range. Now, starting from 1 to num plus 1. Why num plus 1? Because if I write only num, it will generate until num minus 1. So we observed that in the previous example, if n is 7, it will generate from till 6. But I want to include 7 as well. So the value of the input will turn to n minus 1. Basically, in this case, 8. So the range will generate up to 7. Then each number represented by the variable j turns to be the new input number. So instead of asking the user to insert all the numbers from 1 to 7, I am generating these numbers by myself. And in order to make a little bit, to separate the concept, instead of asking the number, I'm asking the maximum number that I want to find. The maximum number I want to reach, and identify all prime numbers between 1 and max number. So I will generate, first of all the sequence. And for each element of the sequence, which is represented by the variable j, I need to do the evaluation that I formerly did. So in this case, we can make use of a nested while as well, where now instead of num I have j, because j is the value that I need to evaluate time by time. So what it was supposed to be inserted by the user will be generated automatically by this range. And the value of the number that I have to evaluate is in the variable j. For example, this will generate a sequence 1, 2, 3, 4, 5, up to max number. The j containing the generated value will be used by what we wrote just some minutes before to evaluate whether the value in j do represent a prime number. And all the code, I have to shift it by one tab, because all this code will be part of this for loop, will be parametric. Beware of this setting, each prime equals to true. This should be reset for every cycle, because suppose we have written the number 7, number 4 is not prime, and for j equal to 4, this variable will return false. But when we pick up the next number, I have to reset my conditions to start from the beginning. So to start from the assumption that the next number that I'm considering is prime. So beware that this instruction should be here and not outside, because this needs to be reset every time we change the number that we are evaluating, mean every time we change j, for each j. Let's run an example. So if I put 2, 1 is prime, 2 is prime. Okay, if I enter 5, so 1 is prime, 2 is prime, 3 is prime, 4 is not prime, as expected, 5 is prime. Okay, let's give a bit larger number, let's say 70. And we have all the sequence of prime and non-prime numbers. The request says that to print only prime numbers and not the others. Okay, in this case, we can skip the print out of the non-prime numbers. So to reduce the list only for the prime numbers, we can as well skip the message that value is prime, because we know that we are printing only prime ones. Let's say 70. And we have only the sequence of prime numbers printed in the standard output. So 70 is not a prime, but let's take as 67 in order to evaluate whether the final value is being considered. Yes. So it stops the evaluation at the exact value that I have entered. So taking into account as well 67, and doesn't stop to 66. So all these numbers are prime numbers. Okay, this was the example that makes use of for, and it includes not only the for loop but the nested for loop. So it's a combination of these two for loops.